Dear students, I am sure that you are eagerly waiting for maths class. Today we will solve a few more problems on chain rule. In the last class we have discussed the derivatives of logarithmic function and exponential function. As we have seen, d by dx of log x is equal to 1 by x. D by dx of e power x is equal to e power x itself, and the derivative of a power x is equal to a power x into log a. So now based on these, let us find the derivatives of some more functions. The question is, differentiate the following functions with respect to x. Differentiate the following functions with respect to x. First, 3 power x. 3 power x. I take this as y. Let y is equal to 3 power x. So you can compare this with a power x. Derivative of a power x is a power x into log a. So derivative of 3 power x will be equal to 3 power x into log a. Next question. E power 4x. Differentiate this. E power 4x. So as always, we shall take this as y. Then y is equal to e power 4x. Now dy by dx is equal to. This looks like e power x. Derivative of e power x is e power x itself. So derivative of e power 4x will be e power 4x into what next? Now I should differentiate that 4x into the derivative of 4x. That's equal to e power 4x into derivative of 4x is 4. So the answer is 4 into e power 4x. Okay. Next, log 3x. Log 3x. We want to differentiate this log 3x. Okay. So I will treat this as y. Let y equal to log 3x. Now y dash is equal to, this is of the form log x. Derivative of log x is 1 by x. So derivative of log 3x is 1 by 3x into what next? Into the derivative of 3x. So y dash is equal to 1 by 3x into derivative of 3x. 3 into x. 3 is a constant and x is a function. So when you have a product of a constant and a function, how do we differentiate? We will keep the constant as it is and we will differentiate the function. So 3 into the derivative of x, which is 1. 3 gets cancelled. So you have y dash is equal to 1 by x. This problem can be solved in another way also. See, you have taken y is equal to log 3x. See, here I have not mentioned the base. Whenever the base is not mentioned, it should be understood that the base is e, which I have already told you in our previous class. So log 3x to the base e, we have. I can use this formula, log mn, which you have seen in the last class. Log mn is equal to log m plus log n. To the same base, I wrote a there, you can write e also. So, logarithm of mn can be written as log m plus log n in the same base. So, log 3x, we can write this as log 3 plus log x. Y is equal to log 3 plus log x. Okay. So, now you differentiate this y dash. 3 is a constant and therefore log 3 is also a constant. So, its derivative is 0 plus derivative of log x is 1 by x. So you have y dash is equal to 1 by x. You can do it in that way also. Next question. 2 power minus x. 2 power minus x. And y is equal to 2 power minus x. Now y dash is equal to, I want the derivative of 2 power minus x. derivative of 2 power x or the derivative of a power x. Derivative of a power x is a power x into log a. So derivative of 2 power minus x is 2 power minus x into log 2 into, we have to find the derivative of minus x. 2 power minus x into log 2 into the derivative of minus x. What is the derivative of minus x? Derivative of minus x is minus 1. So the answer is minus 2 power minus x into log 2. Okay, let's look at the next question. Log sin x. Log sin x. We want the derivative of log sin x. I will call this as y. That y is equal to log sin x. Now when we differentiate this, derivative of log sin x is, so you must imagine this as log x. Treat this as log x. As we know, derivative of log x is 1 by x. So derivative of log sin x would be 1 by sin x into the derivative of sin x. I am using chain rule here. Derivative of log sin x. So first we have differentiated for log and now we will differentiate for that sin. So y dash is equal to 1 by sin x into derivative of sin x is cos x. So cos x by sin x is equal to cot x. Okay, next. Log of x plus root of x square plus y square. This is what I want to differentiate. Given function is log of x plus root x square plus y square. So as always, I will take this as y. Y equal to log x plus root of x square plus y square. Now y dash is equal to, I want to differentiate this. Derivative of log x is 1 by x. So derivative of log of x plus root x square plus a square will be 1 by x plus root of x square plus a square into what next? Now the derivative of this into d by dx of x plus root of x square plus a square. That's equal to 1 by x plus root of x square plus a square into the derivative of x, which is 1, plus the derivative of root x square plus a square. Derivative of root x square plus a square, this looks like root x. Derivative of root x is 1 by 2 root x. So derivative of root x square plus a square is 1 by 2 into root of x square plus a square into what next? Into the derivative of x square plus a square. Into the derivative of x square plus a square. Derivative of x square is 2x. Derivative of x square is 0. Okay? So now 2 gets cancelled there. So you have 1 by x plus root of x square plus a square. Take LCM here. Root of x square plus a square is LCM. This numerator will become root of x square plus a square plus x here. So that x plus root x square plus a square gets cancelled. Finally, we have y dash is equal to 1 by root x square plus a square. Now, some of you may be having this doubt, sir, should we write all these steps? Should we simplify all these things? It depends on what the question they have asked. If the question is only differentiate this function with respect to x, then writing till here is enough. Writing till here is enough. Or if you want, you can simplify, or else write this much if you write, and then also you will get full marks for it. However, in some cases they will ask a question like this: if y is equal to log root x plus root of x square, if y is equal to log x plus root of x square plus a square, then prove that dy by dx is equal to 1 by root x square plus a square. If they ask that question, then you have to prove this. Then you have to do all these simplifications and arrive at this step. Okay? Let's go to the next question. log cos root x. Log cos root x. Okay. Let y is equal to log cos root x. Okay. Now let us differentiate this. Y dash is equal to, this is of the form log x. Derivative of log x is 1 by x. So derivative of log cos root x is 1 by cos root x into d by dx of cos root x into the derivative of cos root x. First we have differentiated for this log, now we have to differentiate from that cos. So that's equal to 1 by cos root x into, it looks like cos x. Derivative of cos x is minus sin x. So derivative of cos root x would be minus sin root x into, now you have differentiated for this cos, we have differentiated for this root x into the derivative of root x. So this will be minus sin by cos, which is minus tan root x into the derivative of root x. Derivative of root x is 1 by 2 root x. So the answer is minus tan root x divided by 2 root x. Next question. Log 1 minus x square by 1 plus x square. Log 1 minus x square divided by 1 plus x square. So we will take as y equal to log of 1 minus x square by 1 plus x square. Before we go for differentiating it, we can use one of the properties of logarithms. Say log m by n. Log m by n is equal to log m minus log m. That formula I can use. So I can write this as log 1 minus x square minus log 1 plus x square. Log 1 minus x square minus log 1 plus x square. Now differentiate it. Y dash is equal to. So differentiating derivative of log 1 minus x square will be, derivative of log x is 1 by x. So the derivative of log 1 minus x square is 1 by 1 minus x square into, now the derivative of 1 minus x square. Derivative of 1 minus x square is minus 2x minus the derivative of log 1 plus x square. I think you have understood. See, first derivative, it's of the form log x. Derivative of log x is 1 by x. So here we have got 1 by 1 minus x square into the derivative of 1 minus x square. Derivative of 1 is 0 minus derivative of x square is 2x. So 0 minus 2x, which is minus 2x. Okay, then here we have log 1 plus x square, whose derivative is 1 by 1 plus x square into the derivative of 1 plus x square, which is 2x. So y dash is equal to minus 2x divided by 1 minus x square minus 2x by 1 plus x square. Okay, next question. Log root 1 minus x square to the base 5. Log root 1 minus x square to the base 5. Let y is equal to log root 1 minus x square to the base 5. Okay. See here, look at all the earlier problems where we had a log, the base was not mentioned. Whenever the base is not mentioned, we have understood that the base is e. Okay, but here the base is given base is 5. We have derived the formula. We know that the derivative of log x is 1 by x. It is true only when the base is e. If it is log x to the base e, then its derivative is 1 by x. If the base is something else, then we don't know what is its derivative. So if the base is something else, then what should we do now? The first thing that we need to do is change the base to e. First we have to change the base to e and then differentiate it. So I want to change the base to e. What are the options I have? The best and the easiest option is change this as e, but that is illegal. You can't do it. Then what are the other options we have? We have that I gave one property, that is change of base rule. I told you. That is, in that I wrote log b to the base a is equal to log c to the log b to the base c divided by log a to the base c. This is what I told you. And I also mentioned that this can be anything. Base, here I have written it as c, you can write anything, whatever the base you want you can write. But you should ensure that these two bases are same. Okay. So here I want the base as e. So what do? I'll write this as log root 1 minus x square to the base e divided by log 5 to the base e. Just compare it. Then we have log b to the base a, I wrote it as log b to the base c divided by log a to the base c. So you imagine this as b to the base a, I am writing it as b to the base c divided by log a to the base c. Okay, that's equal. So 1 by now y dash is equal to. Here you observe this is a variable and this is a constant. E is a constant, exponential constant. Log 5 to the base e, we will keep it as this. While differentiating it, log 5 to the base e will remain as this. You just need to differentiate this. Log root 1 minus x square, I have to differentiate. Okay? So it looks like log x. Derivative log x is 1 by x. So you get 1 by root 1 minus x square. Into what next? Now I want the derivative of root 1 minus x square. Root 1 minus x square, it looks like root x. Derivative of root 1 minus x square. Derivative of root x is 1 by 2 root x. So the derivative of root 1 minus x square is 1 by 2 root 1 minus x square. Into what next? Into the derivative of 1 minus x square. Derivative of 1 minus x square is minus 2x. Okay? You can cancel this 2 and on simplification this will give you minus x divided by log 5 to the base e into 1 minus x square. Root 1 minus x square into root 1 minus x square will give you 1 minus x square. This is the answer. Okay. You can do one more thing. See here, log root 1 minus x square is there. I will give that also. After using the change of base rule, we have ended up getting y is equal to log root 1 minus x square divided by log 5. Okay. Base I have not mentioned, which means base is e. Okay. So now you keep this log 5 to the base a aside because that's a constant that is not going to disturb you. You can keep that space. Here log root 1 minus x square is there now. That is nothing but log 1 minus x square to the power 1 by 2. Root 1 minus x square, I am writing it as log 1 minus x square to the power 1 by 2. Okay. Now this is of the form log m power n. Log m power n can be written as n log m. This is the formula. Log m power n is equal to n log m. You can write any base. Base a, b, c, d, whatever you want, you can write that. Here the base I have not mentioned, which means the base is e. Okay. So root 1 minus x square, I am writing as 1 minus x square to the power 1 by 2. And then log m power n is equal to n log m. See, this is not the property of differentiation. It is not. This is the property of logarithms, which I am using here. Okay. So far I have not differentiated this. So 1 by log 5 to the base e into log 1 minus x square to the power 1 by 2. I can write it as 1 by 2 into log 1 minus x square. 1 by 2 into log 1 minus x square. Okay? Now you differentiate this. This is a constant 1 by log 5 to the base e and this 1 by 2 is a constant will remain as this. Just need to differentiate that log 1 minus x square. So y dash is 1 by 2 into log 5 to the base e into. Now I am differentiating. Derivative of log x is 1 by x. So derivative of log 1 minus x square is 1 by 1 minus x square into the derivative of 1 minus x square. Derivative of 1 minus x square is minus 2x. Okay? Because derivative of 1 is 0 minus the derivative of x square, which is 2x. So now 2 gets cancelled. Then we'll have y dash is equal to, when I cancel this 2, we'll have minus x divided by log 5 to the base e into 1 minus x. Here also we got the same answer. Minus x divided by log 5 to the base e into 1 minus x square. Okay, is it clear? Great. Then we shall go to the next problem. Next problem is log x. Okay, this is the function we have. Log x. Base they have not mentioned. So not mentioned means you must understand that the base is e. Well, okay. So as a customary practice, I'll call this as y. Let y is equal to log x. Now y dash is equal. You treat this as log x. Okay, so log x, right? So derivative of log x is 1 by x. That means you get that 1 by x in place of x we have log x into derivative of this factor, derivative of log x. Up. That's equal to 1 by log x into derivative of log x. Treat this as x. Okay? Treat this much as x. Then it's on the form log x. So derivative of log x is 1 by x. That will give you 1 by log x into what next? Into the derivative of this factor into d by dx of log x. Okay, that's equal to, we have 1 by log x into 1 by log x into the derivative of log x. Derivative of log x, it's of the form log x. Derivative of log x is 1 by x. So derivative of log x is 1 by log x into the derivative of log x. Okay, so this is equal to 1 by log x into 1 by log x into 1 by log x into 1 by x. Okay, see, I'll just explain again. You have log x. First we will imagine this as x. So derivative of log x is 1 by x. First we have differentiated for this log, and then we have to differentiate for this log. Okay, derivative of log x. So we treated this as x. Derivative of log x is 1 by x into the derivative of this factor. Now I am differentiating this. Derivative of log x, treating this as x. Log x, its derivative is 1 by x. So the derivative of log x is 1 by log x into the derivative of log x, which is 1 by x. Okay. Now you must have understood why this is called chain rule. Okay. Next. Next question. 2 power x by 2. 2 power x by 2. If you want to differentiate this, then y is equal to 2 power x by 2. Then y dash is equal to, it looks like 2 power x. Derivative of 2 power x is 2 power x into log 2. So derivative of 2 power x by 2 is 2 power x by 2 into log 2 into the derivative of x by 2, d by dx of x by 2. That's equal to 2 power x by 2 into log 2 into the derivative of x by 2 is 1 by 2. Okay. Next, derivative of we have to find the derivative of 4 power 7 power x square. 4 power 7 power x square. And got it as y. Let y is equal to 4 power 7 power x square. Then y dash is equal to, you treat this as x. Okay, this factor, this much as x. So this looks like 4 power x. Derivative of 4 power x is 4 power x into log 4. So the derivative of this will be 4 power 7 power x square into log 4 into the derivative of 7 power x square. Okay, that's equal to 4 power 7 power x square into log 4 into derivative of 7 power x square. It looks like 7 power x. Derivative of 7 power x is 7 power x into log 7. So derivative of 7 power x square is 7 power x square into log 7 into the derivative of x square. Okay, that's equal to 4 power 7 power x square into log 4 into 7 power x square into log 7 into derivative of x square, which is 2x. Okay, understood. Now I'll solve one more problem so that you will get to know why this is called chain rule. Two power 3 power 4 power 7 power sin x. Okay, 2 power 3 power 4 power 7 power sin x. Let's call it as y. Y is equal to 2 power 3 power 4 power 7 power sin x. Now y dash is equal to, this looks like 2 power x. Derivative of 2 power x is 2 power x into log. So 2 power x, x means 3 power 4 power 7 power sin x into log 2 into what next? Into, now I have to write the derivative of d by dx of 3 power 4 power 7 power sin x. Okay, that's equal to 2 power 3 power 4 power 7 power sin x into log 2 into, this looks like 3 power x. You can imagine this as x. 3 power x, derivative of 3 power x is 3 power x into log 3. So this will become 3 power 4 power 7 power sin x into log 3 into what next? Into the derivative of 4 power 7 power sin x. Okay, that's equal to 2 power 3 power 4 power 7 power sin x into log 2 into 3 power 4 power 7 power sin x into log 3 into, now the derivative of 4 power 7 power sin x, it looks like 4 power x. Derivative of 4 power x is 4 power x into log 4. So derivative of this would be 4 power 7 power sin x into log 4 into d by dx of 7 power sin x. Okay, that's equal to 2 power 3 power 4 power 7 power sin x into log 2 into 3 power 4 power 7 power sin x into log 3 into 4 power 7 power sin x into log 4 into 7 power sin x we have. It looks like 7 power x. Derivative of 7 power x is 7 power x into log 7. So derivative of 7 power sin x would be 7 power sin x into, I'll write here, log 7 into the derivative of sin x, which I'll write now itself, into the derivative of sin x, which is cos x. Okay, so now you have truly understood why this is called chain rule. Okay, so with that I will stop today's class. Thank you.